an autonomous system for creating content, specifically LinkedIn posts. And this is what I tried to build. And I tried to build it based on the Autoresearch repository that was published by Karpathy. It's a very interesting concept, which you can read more about over here. Basically, it's a very minimalistic way to optimize your data, kind of a machine learning process. But I saw many people trying to implement the same mechanism for generating other stuff. And I wanted to see how this will work. Basically, just to give you the gist, the idea is essentially hill climbing, which is a very old optimization principle applied to machine learning research. What you have is you have a file which contains the baseline. Then an agent is going to propose a change, tweak something in the baseline. Then it runs 5 minutes of actually doing the work, and I will show you in a moment what I mean. And then if it is better, the results are better, it keeps the change, and the change becomes a new baseline. And if it is worse, nothing is changed, and basically the work that the agent has done is discarded. Now, in the context of my experiment, we tried generating better LinkedIn posts. Now, this is a subjective goal. So, in according to what other people, I saw people doing, for example, website optimization. So they just took this idea that was proposed by Karpathy and just try to optimize their website page loading speed. So this is objective, which is easier to measure, but I wanted to see what happens when I do it on a subjective goal. Basically, the summary was we did 57 experiments. 24 of them actually yielded a lift, and I will elaborate in a moment what I mean by a lift. 33 were discarded. The initial score that was given to the initial post was 7.43, and the final score was 9.51. Now, what exactly did we do? I took the Autoresearch repository, went to open code, and told it that I want to build a similar, a mechanism which is similar for optimizing a LinkedIn post. And the LLM as a judge, I defined an LLM as a judge. Someone will judge the output of the post. The loop was simple, modifying the prompt every time. We generated 5 posts. The LLM as a judge scored all the posts, and then we decided based on score whether or not we should keep them or discard. One change at a time. So basically we changed the headline, then we changed something in the body, then we added another nuance to the prompt, etc., etc. Every time we made a git commit, and again, if the prompt didn't improve the eventual average of the 5 posts, we discarded it. Now, first of all, what I did, we scraped viral LinkedIn posts from top creators. I just used Bright Data, MCP, in order to scrape LinkedIn posts from Justin Welch and Lara Costa. And basically, this was like a calibration dataset, a Gordy dataset. These posts have a ton of reactions. And so I use them as a reference point. So one post is the perfect day, another one is about the treadmill guy, blah, blah, blah. So building dataset, then we analyze these 15 posts and we extracted some patterns. So hook patterns, bold number plus result, contrarian claim, creating a curiosity gap, and some hooks contained before and after, some showed vulnerability or opened with a confession or one-line verb. In terms of formatting, 1 sentence per line, 3 to 7 words per line in list, extreme white spaces, contractions always, no hashtag, no emojis, question at the end. Then after analyzing these 15 posts that was thread, we generated evals. Evals are ways to measure each post. So the eval, the dimension were how strong is the hook? Would you stop scrolling? Readability and flow, can you scan it in 20 seconds? Engagement quality, would you comment? Value density, what is the insight per line ratio? And authenticity, does it sound like a real person? Then we started the experiment loop. Each cycle, we modified the prompt. Then we committed the prompt. We generated 5 posts. The LLM as a judge scored them and kept the new prompt if it evolved. Otherwise, it resetted. And we did this 57 times. Now let me show you a few interesting milestones. And the thing that was interesting here is how many nuances we realized during the process about writing a better post. So this was the baseline prompt. This was the average of the 5 posts that was generated by the baseline prompt, 7.33. Then we added authenticity rules to the prompt. This yielded a lift in 0.31. Then we decided to add confessions plus hooks. This yielded a lift of 0.36. Then we made more changes. I won't go over everything. These are like the changes that we kept. As you can see, in the first experiment, the second one, then we had 6 experiments that yielded no lift in the average result, so we discarded them. Then on the 8th experiment, we realized we must add to the prompt a more of a confessional style example. Then we did more iterations, as you can see over here. For example, in the 37th experiment, we made it a point to add to the prompt examples of emotional hooks and banned AI cliches. Then we did expanded marketing, unexpected, and etc. etc. You get the idea. Every iteration, every one of the 57 iteration, was built on top of the evals, and we just adjusted the prompt. And more often than not, as I told you, 58% of the time we discarded the results or discarded the adjustment in the prompt. Now moving forward, what worked? So first of all, the example post, the single strongest level, changing the calibration example from an analytical case study to a person-centered story with an unresolved ending, lifted the average by 0.16 in one experiment, changed 3 times total, each time producing a significant jump. Then also banning cliches, second order dynamics, combining near misses, worked very well, no neat resolutions, contradiction hooks. These are stuff that but based on the LM as a judge, yielded good results, basically improved the post. Some stuff that didn't work is, for example, prescriptive requirements. So we had a prompt that said every post must include a direct quote. Adding this mandatory element make posts feel forced and formulaic, and 6 times out of 6 times. So this is very interesting and very insightful. Radical simplification, so cutting the prompt for 99 to 33 lines, lost protective guardrails, score drop from 8.1 to 8. Removing rules only works when the rule is genuinely redundant, etc. So this was very interesting. And eventually, as I showed you, we started from 7.5, the score of 7.5, and we were able, over 67 iterations, to go up to a score of 9.51. Then what I did, I sent 5 different posts that were generated doing all the experiments, like randomly. One was the base post, another one was after the 7th iteration, another one after the 22 iteration, another one after the 57 iteration, like the last one. These are like, as you can see, baseline, which the NLM just said it was 7.43. Then after the 8th experiment, a post that, based on the lemma judge was 8.33, etc., etc. So this was the prediction that was given by the LM as a judge. And then I sent all these posts to a friend of mine and asked him to score them. And he didn't know that post number A was the baseline and that post number E was the final prompt. He knew nothing about the actual experiment. I just asked him to rank what was the best post in his opinion. So this was the way that he ranked them. The first prompt, he gave 8 out of 10. The second post, was 4 out of 10. The third post was 6 out of 10. The fourth prompt was 7 out of 10. And the fifth, and what was supposed to be the best post based on the fact that the lemma judge gave it 951, got a score of 6 out of 10, which basically isn't so good. So the friend feedback was very specific, and based on the feedback, I actually optimized the eval. Now, why is this important? Some key takeaways. First of all, about prompt optimization, it's very valuable to add one change at a time. Multivariable changes make it impossible to know what helped. The example post in this experiment was the strongest lever. Banning cliches versus novelty, at least in this experiment. It's very valuable in your post to combine near misses. When stuck, modify the example, not the rules. Quality improvements are exponential in difficulty. So this was very interesting. About the lemma judge, LM judges read from human real preferences. So this is very important. And use this upfront that basically it's important to have a human annotator, but it was very interesting in terms of the experiment to see what would be the delta between what my friend said and the LM as judge. So LM as a judge developed consistent internal biases over many iterations. It's very important to validate with humans early and often. We ran 57 experiments before one blind test. That's basically 56 too many. The rubric, or basically the eval, is the product. A wrong rubric or parameter for the eval means optimizing for the wrong thing, no matter how many experiments you run. The optimization will perfectly for the rubric or eval, but the eval itself, the parameter was wrong, or at least how the LM as a judge perceived what is important within the parameter. There are a few more takeaways that were generated by AI regarding medium content. So scannability beats depth, actionability beats insight, emotional complexity has diminishing returns, simple vulnerability is enough. The first apparent course was the one closest to the variable reference pairs, short, scannable, list-based and actionable. The optimization loop had drifted away from this format. Yeah, I think that is pretty much it. I just wanted to see how does the auto-research mechanism, how does it work? As I said, it's better to use it with something which has an objective measure. If you use it for something subjective, make sure to have a human in the loop, or at least very often, so you can make sure that the LM as a judge, like the judge that is actually storing, is aligned with your preferences or what you want to achieve, because otherwise you're just running this, it's kind of a half loop. You're just running this loop blindly. So this is also very important. I did use this mechanism also for generating a few landing pages. And it's very interesting to see how the LLM approaches this, how it adjusted the variables and made modifications. Again, the takeaway, but the most important takeaways are, first of all, the importance of evals. And second of all, when it's subjective, you must have a human annotator, otherwise things go sideways very fast. I think that's pretty much it for today. I hope you guys enjoyed this video. If you did, obviously like and subscribe. Until next time, keep on automating.